and a bit about artificial intelligence and how we're going to be using or potentially using AI going forward. If you've got any questions, there'll be time for Q&A at the end. So just save your questions till the end, and I'll hopefully try and answer them all to the best of my ability. So then, a little bit about me. So prior to joining the CAA, I worked in the Royal Air Force for 13 years. I covered a few different areas. So things such as aviation security, so the security of both putting passengers on aeroplanes and also of airports themselves. I also covered critical infrastructure protection, so things like MOD bases and quick reaction aircraft. And latterly in my career, I looked at information security. So looking after the deployable computer systems that the RAF and the MOD use. I then left the RAF after 13 years and worked for a defence contract company in the civil sector, um, where I was what they called a system security engineer, which was a very posh title for basically help writing documentation and accreditation for military mission planning systems. So the picture you see on the bottom left there are some helicopter crew basically planning a mission in the UK using the planning system that we made. And then the right hand side is a picture of a Typhoon pilot with what's called an electronic flight bag, or EFB, which is basically a tablet computer like an iPad, um, with the mission that they've planned on the ground-based system. And it also has like aircraft checklists and stuff on that tablet for them as well. So after I'd done that job for a few years, I then moved to the CAA where I am now, which is the UK regulator, which I will explain what that means now. So those of you that have ever been on holiday on an aeroplane will have interacted with us at the CAA. So part of our remit is to protect consumers such as yourselves. So the bottom left of that picture there, you see the Atoll Protection Scheme, which is a scheme that we run where every time that you book a flight or a package holiday or anything, that atoll scheme basically protects you if the airline no longer exists, which happened with Thomas Cook a few years ago. I think it was 4 or 5 years ago now, where basically the airline went bust. It didn't exist anymore overnight, which basically meant that the CAA then had to repatriate everyone that was stranded overseas back to the UK. And we basically had to charter a load of aeroplanes, send people all over the globe, and get people onto those planes to get them back to the UK. So that's just one part of what we do. We also regulate the commercial industry. So we look at airlines, airports, air traffic control services. We issue licenses to all those people. We also look at, making sure they're adhering to international regulation and requirements. We also oversee general aviation, so those people with private pilots licenses. We also look at the safety and security of flying. So when you go through an airport and you go through airport security, we oversee, what the equipment is they're using, how those people are trained, all that sort of stuff. And we also do a lot of data and analysis, which leads into the international work we do. So we're part of what's called ICAO, which is the International Civil Aviation Organization, which basically is an international governing body which oversees regulation throughout the world. And we help to sort of define how that looks and what the regulations look like. So a few facts and figures then about civil aviation. Um, so the world's oldest airline, unfortunately, isn't British. It's KLM, the Dutch airline, and they were established in 1919. So they're over 100 years old now, 125 this year. Um, Another interesting fact, so Chicago O'Hare International in the USA has an aircraft that takes off or lands every 37 seconds, which I think is quite amazing, to be honest, when you think over the course of this presentation, how many aircraft have taken off or landed at that one airport alone is quite mind-boggling. The aircraft you see in the picture there on the right-hand side is an Airbus A380, which is a double-decker aircraft, but the aircraft is actually wider than it is long. So the wingspan you see there is 80 meters wide, but the actual length of the aircraft is only 72 meters. So it's actually wider than it is long, which again is quite crazy. Another interesting fact is that American Airlines, so a lot of airlines used to carry around big paper manuals and charts and checklists and things. And American Airlines was actually the first airline to think we can digitize all this stuff and put it on an iPad. And they actually worked out that by just carrying the iPad round rather than all these books and manuals and things, they saved themselves around $1.2 million in fuel alone, which again is a bit of a crazy statistic. And one final one, the busiest day recorded in aviation was actually in July 2019, so just before COVID, where we had nearly 250,000 flights worldwide that day. So a very busy day around the globe. So moving on from that then, a little bit more about me and my team. So I head up the cyber security certification team, which basically means I have a team of 5 people that cover these 5 main areas. So my team look at RPAS or drones as they're more commonly known. Um, so we look at the sort of safety of commercial use of drones, and as it says there, sort of aerial surveys or big swarm displays like you see over Parliament on New Year's Eve. So when they have the big display over the Thames, that's one of the things that we look at. The other area is initial airworthiness. So things like that big Airbus airliner or large business jets, we look at the sort of security risk assessment of the networks within those aircraft to make sure that they're safe. We also cover space. So the CAA not only covers aircraft, we also cover space. So there's 2 guys in my team that cover all 5 types of space license. And you probably saw at the beginning of last year, there was a space launch by Virgin Orbit from Spaceport Cornwall that unfortunately didn't quite make it into orbit, but it was the first attempt on UK soil, with hopefully another one happening early in the new year from a site in Scotland. So watch this space on that one. We also cover air traffic management. And the example I've got there of London City is an interesting one, and I'll cover that a bit more as the presentation goes on. But it links nicely into the last area we cover, which is innovation. So as I've already mentioned, we're looking at things like artificial intelligence and advanced air mobility, which is another thing I'll cover later on. So current technology in aviation then. So the aircraft you see there is a Gulfstream G700, which is actually one of the aircraft that we certified in the UK about 2 months ago. 2 of my team were involved in the certification of that. Unfortunately, we didn't get a ride on one, which was very upsetting. But that's how traditional aircraft pretty much look at the minute. And those aircraft utilize several different electronic systems, which is what me and my team are predominantly looking at. So top left there, you have navigation systems like GPS. So for about 30-ish years now, we've been reliant on the US military GPS system for position, navigation, and timing. So a lot of aircraft systems are heavily reliant on GPS to get from A to B. Um, Bottom left there, you have a communication system. So that's what's called an MDLS system in a commercial aircraft cockpit. And part of that system, you can communicate with air traffic control um, with something that's called CPDLC. And CPDLC basically uses like text messaging for aircraft, basically. So it allows you to communicate with air traffic control without having to physically talk to them, basically. You can just send them a text message and say, I want to do this, can you clear me? And then they'll send you a text message back that says, yep, that's fine. We will clear you to go away and do that. Just get the slides back. So as well as CPDLC, they also have another communication system which allows them to talk to their operator. So if it's an EasyJet aircraft, for example, they can send a message to EasyJet maintenance to say, we've had a maintenance warning come up on the cockpit. So can you make sure the aircraft's booked in for maintenance when we get on the ground? Which is one of the things you see on the right hand side there. So that's an engine undergoing maintenance. And a lot of aircraft engines now have sensors that have sort of communication systems on them. So they're constantly transmitting to the engine manufacturer to say, you know, I'm running at these temperatures and pressures, and I have this amount of vibration, and this is when I think that I'm going to be needing to come in for maintenance. And then top right, we have planning systems. So again, you see that tablet that I spoke about earlier, where they're doing their route planning and they get their weather and all that kind of stuff on their tablet, so that they can plan their routes before they actually get to the aircraft. So as I mentioned at the start, another piece of technology that's being used right now at London City Airport is what's called a digital tower. So traditionally, we had people stood in air traffic control towers looking up and down the runway to issue clearances. So they had to visually see for themselves that the runway was clear before they could issue a clearance for an aircraft to take off or land. But nowadays we have modern technology with cameras and sensors where they can actually do that from a completely different site. So the picture you see there is London City Airport, not far from Canary Wharf on the side of the River Thames. And those two people sat in that control room are actually watching that image from a control center in Hampshire, about 150 miles away. But because of the technology, they can see up and down the runway, they can hear what's going on, and you might be able to see in that picture there's sort of green dots along the skyline, and that's basically picking up objects that are moving in the sky and highlighting it to the operators so that they can see what's going on, and it's easier for them to pick up any movement that's going on around the airfield. In terms of other technology, we're seeing more and more use of drones. So as I've already mentioned, things like the light display that you see on New Year's Eve in London, that's done with a swarm of about 500 drones. People are also wanting to do more aerial photography and things with them. So a lot of like movie makers are using drones rather than helicopters now. And you can use them to do aerial surveys of things like buildings or as I've written there, a good example is power line inspection. So National Grid and the energy companies used to have helicopter crews that would go out and fly up and down power lines to do inspections. Whereas nowadays they can do that with drones, and it basically takes away the risk of something going wrong with the helicopter and either harming the people on board the helicopter or wiping out the power lines. It's obviously much less risky to use a drone to do that. So, what does the future look like then? So, those of us of a certain age will remember about 25 years ago, there was something called Concorde, and Concorde was able to fly at twice the speed of sound, which meant that you could fly from London to New York in between 3 and 4 hours, um, whereas now it takes sort of 7 hours to do it. So the aircraft you see there is called the Overture, which is made by a company called Boom Supersonic. And they're looking to basically replace Concorde as the next supersonic airliner. Um, they're hoping to certify it and get it flying by 2029. So watch this space. It might be something that you see in the skies in the not too distant future, which would be good because it's about time we had a replacement for Concorde 24 years after it retired. One of the other emerging technology areas we're seeing is advanced air mobility or urban air mobility, as it's called. Um, this basically uses battery technology similar to what you have in an electric car to basically provide an electric vertical takeoff and landing aircraft like you see in those two pictures there. And the idea behind these is that you will be able to fly either within cities or from city to city without sort of having to jump in a car or take a train, which hopefully will reduce the sort of emissions if these things all run on electricity. Um, so a good example of this is if you had to get from two London airports, such as Heathrow and Gatwick, which are the opposite sides of London. At the minute, you're talking an hour and a half by either train or bus. Whereas if you could jump in one of these things, you could do that journey in 20 to 30 minutes. So much quicker, much easier, much more efficient. Um, what they are working on is getting sort of extended ranges and operating temperatures from the batteries. So, like I say, it uses similar battery technology to what you get in electric cars, which obviously is evolving all the time. And there's a company in China that have developed a solid state battery for these types of aircraft, which has pretty much doubled the range and capability of them. So again, watch this space. A lot of these manufacturers are aiming for certification between sort of 2026 and 2030. So you might start seeing these things popping up in the not too distant future. Um, we currently have a couple of drone delivery trials going on in the UK. Um, so using drones to deliver things like medical supplies, food, or sort of lightweight packages that the drone's able to carry. Obviously saves using delivery vans and things, particularly in congested areas. Um, so a lot of logistic companies. So we'll use Amazon as an example. So it's easy for Amazon to get stuff to a big Amazon warehouse. What's more difficult for them is getting that stuff from the Amazon warehouse to your front door, which is where they're trialing the use of this drone technology. to obviously cut down on the amount of vehicles and stuff that they've got to put on the road. There are obviously limitations with the weight of the payload it can carry in, weather conditions it can operate in, and that kind of stuff. But as I say, this stuff's currently being trialed, and similar with the picture you see on the right hand side there, we currently have another drone trial going on in London, which a couple of weeks ago did its first delivery of blood samples from one London hospital to another. And that trial continues, in the hope that we can obviously start to use drones to again cut down on the amount of congestion on the roads, and use airspace to its full capability. And again, as I mentioned previously at the beginning, we're seeing more and more use of artificial intelligence. So you probably see AI in the news most days. It's a bit of a buzzword at the minute, but for us in aviation, we tend to base our safety on, lessons learnt from the past and historical data that we've gathered over 100+ years of flying now. Um, and AI is basically the new kid on the block. So before we start using AI all over the place, there's a few things that we need to assure ourselves of first. Um, so AI is definitely not replacing pilots anytime soon. Um, Pilots are very much a safe sort of industry to be in, mainly because we have a lot of trust in pilots. They're very highly trained. They practice a lot of failures and things. So at the minute, there's absolutely no plans to replace pilots with machines. Um, AI is also not controlling the skies. So again, air traffic controllers are very highly skilled, very highly trained people with a lot of responsibility. Um, and we're just not in the position of confidence with AI to start saying, well, we're gonna, strip out air traffic controllers and replace them with machines. Um, Partly because of that last point there, where we're not in a confidence place where we can let AI make unsupervised, safety critical decisions. Um, so what you see in the second bullet point that AI is doing is providing suggestions and recommendations to humans. So what AI is good at is analyzing complex situations or analyzing large amounts of data very quickly, to provide the pilot, the air traffic controller, the engineer, whoever it may be, with a recommendation of what they should either be looking at or what they should be actioning. Um, and it's also very good at automating repetitive tasks. So things like filing flight plans or going through, historical engineering records. It can do very quickly and very accurately, which then means it's providing another layer of the safety net. So if you're an air traffic controller, I'm going to pick at Heathrow again because it's extremely busy at Heathrow. Um, Having AI there as a backup person over your shoulder, giving you suggestions or highlighting things that you might have missed, can be extremely helpful, because we're all human at the end of the day. We all make mistakes. So having that other layer of safety to give you is obviously very helpful. And this slide gives you some of the benefits. So as I've demonstrated there, we're already seeing use cases in a lot of these areas, um, and predictive maintenance is one of them. So a lot of aircraft engine manufacturers implement what they call engine health monitoring. So it takes all that sensor data that I described earlier from these engines that's being fed 24/7 to control centers. And it basically creates huge databases of engine performance criteria, engine failure rates, when maintenance will more than likely need to be carried out. And then it can highlight that to engineering departments and aircraft operators to say, well, I've been analyzing this flight for the last 20 minutes and I've seen parameter X, Y, and Z, which I think means that the engine will probably need to go into maintenance within the next 100 hours or something like that. So what it's very good at is, analyzing huge amounts of data and giving that suggestion to the human being. Another use case we're seeing is the cross-check of readbacks given by flight crews to air traffic control. So every time an air traffic controller issues a clearance to a pilot, the pilot then has to read that clearance back so that the air traffic controller knows that they've understood what they've been told to do. You won't be surprised to learn that that doesn't always happen, or it doesn't always happen correctly. So what we're seeing is AI-based systems that analyze those voices and provide a transcript of what's being said so that the air traffic controller can read what the pilot has read back and assure themselves that what they've told the pilot is actually what the pilot's repeated back to them. So not only are they relying on what they're hearing, they can also read it on the screen in front of them, giving again that additional layer of safety net and that extra bit of assurance. We're also seeing AI systems in airport baggage screening confirmation. So, like I said earlier, when you go through an airport, you go through the security lanes, and they X-ray all your hand luggage that you're taking on, to make sure that you haven't got any prohibited articles in there. And what we're starting to see trialed at the minute is machine learning based systems that are analyzing huge data banks of images of bags, and picking up prohibited articles in there and flagging it to the X-ray operator. So again, it's not making that decision of I'm stopping this bag and I'm rejecting it. What it's doing is flagging a bag to the operator and saying, I think there is an issue here that you want to look at. So providing that additional safety net again. Another benefit of AI is weather avoidance. So as we've all seen over the weekend, bad weather can cause havoc for aircraft. But again, one of the things AI is good at is analyzing huge amounts of historical weather data and weather patterns, and suggesting alternative routes to aircrew to try and avoid the worst of that weather. So if you're flying over the Atlantic, it might say that you need to fly a slightly more northerly track, or it might say you need to fly at a slightly higher altitude, to avoid the worst of the weather in that area. And again, that's in addition to the weather radars and the things that the aircraft have fitted already. And the images you see on the right-hand side there are airfield signage recognition system. So another one of the use cases we're seeing is an optical recognition system. So when a flight crew is given a taxi clearance at an airport, if they're told to use taxiway Charlie, and continue on to Delta, but they actually turn right on Charlie 2 there, the system will flag up to them and say, hang on a minute, I know that you've been cleared along Charlie to Delta, and what I've read on the sign here is that you've turned right onto Charlie 2, which you weren't cleared to do. And it'll flag that for the pilot so that they know they've made the mistake, and then they can get in contact with air traffic control to find an alternative route. it's also being configured to look at things like runway hold bars. So when you move from a taxiway onto a runway, you have what's called hold bars where you're supposed to hold unless you're cleared to continue. And what the system will do is flag if you encroach past that hold bar without a clearance, to stop pilots going onto the runway without being cleared. So they're just some of the use cases we're seeing right now for AI. And like I say, they're all very much in the early development stage, because we're still learning a lot about this technology, which also means we have a lot of challenges as well as benefits. Um, and a lot of these challenges are based on, industry versus regulator agreement. So us as the regulator, we're tasked with keeping the flying public safe. So we want to, keep these systems as safe as possible in order to protect you guys. But what the industry want to do is sort of, pioneer this technology and use it as much as possible and as widely as possible, which is fine given time, but we need to sort of walk before we can run. Um, and that leads into the second bullet point there of sort of training data and the adequacy of training data, because a lot of these AI systems rely massively on training data to get the outputs that you need, and the sort of assurances that are required. Um, and again, that leads into the decision making process. So a lot of these things are based on, how much training data you've used, how big is the training data set, how long have you tested it for, have you tested it for unexpected inputs, does it shut down completely or does it flag that you've given it an unexpected input? And we need to know that whole decision making process before we can certify it and allow people to use it. Um, the other side of AI is where cyber criminals are using it, against airlines and airports. So you get things like very cleverly crafted phishing emails that encourage people to click on a link that, takes them to a website that can potentially download malware onto their machine. And AI is basically allowing these cyber criminals to perfect these types of attack all the time. And the more and more they do these types of attack, the more and more accurate and harder to spot they become. So they're just some of the challenges we face with AI. And lastly, I just wanted to quickly cover the sort of challenge we have with airspace modernization. So, I've covered all the people we look after and the areas we cover. But now we need to sort of figure out how we allow these people to share our airspace. So you've got all these private pilots flying around, you've got drones buzzing around, you've got these urban air taxis, you've still got commercial airliners and cargo planes, and then you've got military aircraft flying around, and we've only got a finite amount of space. So how do we make sure that we deconflict all these people, to make sure that, everyone remains safe at all times and everyone knows where everyone else is at? Um, Again, it's another challenge that we face. It's another piece of the technology jigsaw that we're gonna have to figure out, and we're sort of halfway through this journey at the minute to figure out, how do we modernize the UK's airspace, to let everyone use it as fairly as we can. So that's it in terms of, you know, what what we have now, what we're potentially seeing going forward. I'm just going to finish up with, if you're interested in a career in aviation, how can you be part of it? So this picture just gives you a small snapshot of, some of the careers and opportunities that are open to you. Um, Again, many of these things you can do in the air cadets, like gliding, flying, general aviation, visits to military units, airfields. Um, so I'd encourage you to take all the opportunities you can while you're in the cadets. And like I say, if it's something that interests you and you see something in that picture that you think, yeah, I wouldn't mind doing that as a living, um, then you can scan that QR code and that will take you to our STEM website. And it's not just run by the CAA. There's a lot of um, companies that have input into our website. So there's people like Rolls-Royce, British Aerospace, National Air Traffic Services. There's a lot of big, companies and airports and stuff that feed into that website and give some like day in the life of information or, routes into careers or what's good from an education pathway perspective. Um, and also, if you're not sure what you want to do, then there's like a careers questionnaire on there. So you can input, this is what I'm interested in. These are some of my hobbies. This is what I do in my spare time. Um, and it will give you at the end of that questionnaire some interesting sort of job recommendations and job profiles to go away and research and have a look at on the website. Um, But other than that, that's it for the presentation. I'll take any questions. I know there's some in the chat, so I might.
I think there's some in the chat. I was just
Yeah,
about to say.
I'll start with the chat first. So I think the demonstrator question was about Boom Supersonic, and you're right, they do have a demonstrator, and it did a test flight about 2 or 3 weeks ago. Um, it hasn't broken the sound barrier yet, but I'm told that they're hoping to do the first supersonic flight at the start of next year. So in the next sort of 2 months or so, we should see that Boom Supersonic actually going supersonic, which will be good to see. Uh, Cost of digital towers. Um, I I did know an exact figure of the one at London City, but I can't remember it off the top of my head. Um, they're not cheap. There's a lot of technology involved in getting them set up. But a lot of these sort of digital tower projects are designed to last 10, 15, 20 years. Um, so when you factor in, recruiting air traffic controllers, the cost of wages for air traffic controllers, the cost of, getting them to and from these airfields, um, I'm guessing it works out that in a lot of cases the digital tower is more effective than having someone physically there in the tower. Um, and interestingly, a lot of the Scandinavian countries have digital towers. So Sweden, for example, um, they have one of the largest digital tower networks where they have about 8 or 9 airports connected to one monitoring center, purely because a lot of the Swedish airports are very remote and they struggle to recruit people who are willing to go and work in these remote areas. So they figured, well, actually, we could just put a control center in the middle of Stockholm, and then, it's easy for people to get to work, and we can just monitor all these airfields remotely. So the Scandinavians are doing this quite heavily already. Um, Next question again on digital towers. If the cameras get damaged or don't work, so basically they have, in order to get these systems signed off, they have to have multiple layers of redundancy. So all the camera pictures you see there, basically the cameras are designed to overlap each other. So if one camera fails, then basically the cameras either side of it can pick up that patch of sort of dead camera space in effect so that you don't lose coverage. Um, they also have to have multiple layers of like internet connectivity and power resilience. So they normally have like two separate fiber optic communication links, two separate power links to the digital tower, so that if they have a power cut or if their broadband provider goes down, then they have another system that they can then rely on to keep the air traffic flow going. Hopefully that answers that question. Uh, do I think that AI will replace pilots in the future? Personally, I think we're a very long way off that. I think maybe in the next 15 to 20 years, you might see us reduced down to single pilot operations, but there's still a lot of controversy around that. Um, I think the more we get sort of public confidence and reassurance in how AI functions, like I say, I think it's probably more realistic that we'll reduce to sort of single pilot ops for commercial aviation. Military, you might start to see AI replace military pilots sooner than you see it in commercial aviation, purely because the military are already at single pilot op um, capability. Plus the fact that if you strip the human out of a military cockpit, then the jets and things can take a lot more stresses, so you can pull a lot more G, you can carry a lot more payload underneath, that kind of thing. So I think you'll probably see more of a military push to replace pilots than you will in commercial aviation. Um, but again, we'll see what the pilot union says about that. Aerialis, I have heard of that unmanned aircraft, and I can't remember where I've heard it from. Um, and again, Adams mentioned Airbus suggesting single pilot operations. Yeah, like I've said, I think in maybe 10, in probably more like 15 to 20 years, I think the idea of single pilot ops will probably get pushed a bit more. But again, I can't see into the future. I don't have all the answers, unfortunately. You'll probably know better than me when the time comes round. Um, Flying cars. So flying cars are an interesting one. Mainly from a regulatory perspective, really, because it's very difficult to um, comply with rules of the road and rules of the air at the same time. So you tend to see demonstrators of flying cars, but you don't see many actually come to market for people to buy, mainly because it's so difficult to do. Um, Virgin Orbit test flight. I personally don't think we'll see another Virgin Orbit launch in the UK. I hope they prove me wrong. But basically, when their um, flight in the UK failed to get into orbit, they basically packed up their UK operation and went back to America again. And because of the costs and stuff of bringing everything back over to the UK from America, there's much more companies in the UK and Europe now that are looking to do a UK launch rather than Virgin Orbit. So I think if Virgin Orbit do go again, um, then they'll probably end up going from America, but they're not in a particularly financially stable position right now. Um, the maximum weight a drone can carry, it varies massively depending on the size of the drone and how many rotors it's got and on all that kind of stuff. Um, the I think the biggest load carrying one I've seen could carry about 50 kilos, but you're talking like big commercial sort of freighter drones in that sort of aspect. And when I talked about urban air taxis earlier, there's actually variants of those eVTOL aircraft that are designed for freight. So that might become a more viable option than actually using a drone to carry huge weight. You'll just sort of scale up to, an eVTOL aircraft as a freighter rather than using a drone, purely because it'll enable you to carry much more weight and make it more worthwhile. Uh, for aerospace engineering, will cadets put you in an advantageous? I'd definitely say so. So, um, when you're going for job interviews in aviation, the we get hundreds of CVs from people who have, been to school, been to college, been to university. That's great, but you need to demonstrate, what you do outside of academics, what you do in your spare time, and things like air cadets and, going out to your nearest airport or whatever and doing some work experience will put you in a massive advantageous position because it will jump out on the CV that, okay, this person's, got great A levels, they've got a degree, but they've also gone out of their way to learn a bit more about the industry and, they've gone away and done, an air cadet summer camp at an airfield, for example. If you go to Bryce Norton, Bryce has, got a lot of big, heavy transport aircraft there, similar to what we get in commercial aviation. So things like that obviously will help massively. Um, but yeah, one of the biggest tips I give to people for CVs and job interviews is, keep a CV to 2 pages, because a lot of companies will automatically filter out anything that's more than 2 pages. And also, demonstrate what you do in your spare time. So, go and join a local flying club, even if flying is too expensive, just go and help them out or something. Because a lot of the time, if you, I don't know, go and help them clean the aircraft or help them look after the clubhouse or whatever, they will, as a reward, they will then go and give you some, flying time or whatever. There's always opportunities out there and people that want to help you. So anything you can do in your spare time is a massive advantage. Next question, will AI affects people's jobs, careers? I think it already is, to be honest. So a lot of stuff that, you used to have to pay website developers or, computer coders to do, you can now get ChatGPT to write you a web page using I don't know, JavaScript or whatever it may be, and it will just go away and do that for you, given using the brief that you've given it. So I think AI is sort of already having that effect on job careers. So yeah, be careful what job career you pick because you might get replaced by a machine, but probably not for a little while yet. Um, how will new environmentally safe aircraft keep up with the larger fuel-reliant aircraft in the future? Again, this is an interesting topic of conversation that we're having within the CAA. We obviously are keen to decarbonize flying as much as we possibly can, which is why we're looking at all sorts of different methods. So eVTOL I've already spoken about, so using battery technology. We also have a big hydrogen program, so using hydrogen either on its own or um, in connection with eVTOL. So using hydrogen as a range extending capability to those battery powered aircraft. Um, and alongside those two things, we also have SAF, which is sustainable aviation fuel, which is basically a blended mix of stuff that's made in a lab to basically replace, burning traditional fossil fuels. So we have sort of 3 areas of opportunity that we're exploring at the minute, um, not only to help develop the aircraft of the future, but also keep our current aircraft, keep burning as little carbon as possible for as long as we can before the new technology is ready enough. Um, Next question, with the drone delivery system, what safety measures are taken? So again, drones are a very complex topic. Um, at the minute, the sort of trials that we have ongoing are in areas that are not densely populated for this specific reason, because we have to assure ourselves that the safety measures that these companies are putting in place are going to be good enough. And when they do get the green light to start operating, they're not going to be operating in city centres. So if you're in a rural community in Cumbria, for example, it's much more easy for us to authorize, a drone delivery service in Cumbria than it is in central London, because the overflight risk is dramatically reduced. Um, one from the drone itself hitting somebody, but two from the drone accidentally releasing its payload and dropping an Amazon parcel on someone's head, for example. Um, so once the sort of test flights are done and we have a sort of basic level of assurance, it will then be a case of us, slowly but surely widening the barriers so that they can start to sort of prove what they're doing is working, before it's going to be a little while before you start seeing these things in busy areas. Um, so if you live in a rural area, you might get an Amazon delivery before anyone else. So it's not always bad living in the country. Next question, maximum altitude for advanced air mobility. So a lot of them have a ceiling height of 10,000 feet, mainly because they're not pressurized. So if you fly over 10,000 feet, you either have to pressurize the cabin or everyone has to wear oxygen. So a lot of the designs are just going no higher than 10,000 feet. And if you're flying, from one side of a city to another, or from, Birmingham to London, for example, it's not really worth going above 10,000 feet because by the time you've climbed up there, you're already starting to descend again. Um, what GCSEs do you need to join the Air Force? Last time I checked, I think it was three GCSEs, including maths and English, but that might have changed. So don't quote me on that because I joined quite a while ago now. So um, I'd double check the Armed Forces Careers website first. Um, but yeah, you don't need like 10 GCSEs at grade one or whatever. It's pretty straightforward in terms of qualifications. Mainly because a lot of the trades in the Air Force now will give you apprenticeships and things when you join. So even if you don't do particularly well at school, there's ample opportunity to train and learn once you're in the military. They invest a lot of time and effort in their people. Uh, any more before I have to disappear? Didn't Virgin Orbit use a 747? Yes, they did. It was a modified 747, and it basically had a pylon on one of the wings, where they strapped the space rocket to that pylon, and fired it into space from under that wing, which that bit all worked fine. Unfortunately, it was a blocked fuel sieve that basically meant that it wasn't delivering enough fuel to the rocket, which was why it couldn't then make it into orbit, which was quite annoying for them because this fuel filter was, a couple of dollars, and it basically scuppered their entire mission for the sake of a couple of dollars, which was very annoying. Um, and I think I'll end it there because otherwise I'll probably be here all night. But thank you all for listening, and hopefully I've answered most of your questions.